Hi everyone, let's look at problem 3.6 from the textbook. The stresses at a point in a bar are 200 Newton per mm squared, and this is a tensile stress, and 100 Newton per mm squared, which is a compressive stress. Determine the resultant stress in magnitude and direction on a plane inclined at 60 degrees to the axis of the major stress. Also determine the maximum intensity of shear stress in the material at the point. Now, let us first look at what we need to draw. If you consider your member and you'll have this is your major stress and this is your minor stress. All right, and let us consider this as sigma 1. He's saying that this is 200 Newton per mm square. All right, and this is sigma 2, which is 100 Newton per mm squared. All right, now he's also saying that this is a compressive load, so this will be minus 100 Newton per mm squared. Now, what other information is given? He's given that the plane or the inclined plane, let us consider the inclined plane. I'll change the color. We'll have an inclined plane. All right, this inclined plane is making an angle of 60 degrees to the axis of the major stress. Now the axis of the major stress will pass through here. Now this angle is 60 degrees. Okay, the important thing to note is we are interested in this angle. This is theta for us. So if you look at this triangle, the small triangle, theta will be equal to 180 minus 60 minus 90. This is 90 degrees. So your theta is equal to 30 degrees. All right. Now we already have sigma 1 is equal to 200 Newton per mm square, and sigma 2 is minus 100 Newton per mm squared because it's a compressive load. Now he's asking us to find out the resultant stress in magnitude and direction on the plane. Now to find out the resultant, we just first need to find out sigma n, and the formula for sigma n in this case is sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 cos 2 theta. Now sigma 1 is 200 plus 100 by 2 plus 200 minus 100 by 2. Sorry, this also be minus or minus 100 cos 2 times 30. So you will get this as 200 minus 100 by 2 plus 200 plus 100 by 2 cos 60. Now this will be 100 by 2 plus 300 by 2 cos 60. So this will be 50 plus 75, sorry, 150. 150, and cos 60 is 1 by 2. So this will become 50 plus 75, which is equal to 125 Newton per mm squared. This is sigma n. All right, now we need to find out sigma t. The formula for sigma t, as we know, is sigma 1 minus sigma 2 by 2 sine 2 theta. 200 minus 100 by again by 2 sine 2 times 30. Now this becomes 200 plus 100 by 2 sine 60. Again 300 by 2 sine 60. 300 by 2 is 150 times sine 60 is 0.866. Now when you multiply this, you get 129.9 Newton per mm squared. This is sigma t. Let's put this in a box as well so we know what values we have to use. Now he's asking you to find out the resultant, sigma r. We know sigma r is equal to root of sigma n square plus sigma t square is equal to root of sigma n is 125 square plus sigma t is 129.9 square. Now resolving this, you get 180.27 Newton per mm square. This is sigma r. This is your first answer. Now he's asking you to find out the obliquity. Now let's go back to the question. He's asking you to find out the direction of the inclined plane. The inclination is given by your obliquity. Obliquity is nothing but tan phi is equal to sigma t by sigma n, which is equal to 129.9 by 125, or phi, tan phi is equal to 1.04, or phi is equal to tan inverse 1.04, which will give you 46.6 degrees. This is your second answer. Now he's also asking you to find out the maximum shear stress. We know the maximum shear stress is given by the equation sigma 1 minus sigma 2 by 2, because sine 2 theta will be 1. That is when you will have this as maximum. So substituting 200 minus of minus 100 by 2, which is equal to 300 by 2, to 75. Let's get it down here. Yeah. 150. Wonder why I get 75. This is sigma t max. Quite simple direct substitution, and in the next video we'll look at another problem that should give you enough confidence to understand how the numericals are worked out.